Uh, let's start. No, let's start. I'm going to show the board. Can you see the board now?
Yes, sir.
Na may
Yes,
makita.
sir.
O, sige, sige. Tubag ra mo dayon ha kay aron kuan. Don't worry about mura ra gud nas klase ba. Kay aron we will have a smooth and very meaningful conversation, okay? Kuan anang maybe what you know is not the right one, or what you know, you can confirm that what you know is the correct one, or what you know is the not the right one. Okay, or you do not know, no? So sige, pangutana gyud ha. Do not hesitate to. Okay, so I'm going to spotlight. You spotlight pin the board and then spotlight it, no? And then it's better if you have a full screen so that you will have bigger. Okay. So again, good afternoon, class. We will now have, as if you remember, we stopped last time. We stopped at the longitudinal or transverse shear stress. So this is an example of this problem is an example for the transverse application of how do you determine the transverse or longitudinal shear stress of a beam shown in the figure. Okay. Now, what is important with this problem is we have an example where the beam is not a regular rectangle, not a regular circle, but an inverted T, which means this is a composite. No, this is a composite figure, meaning you can subdivide this into rectangular, no? Rectangular portions. No? The cross-section, you can subdivide it into rectangular cross-sections. But first, before we go there, let's look at the problem. Do you know what is this kind of beam? Where the support is only on one end. The support is only on one end. There are no other supports here. Wala mo kakuan sa inyong
Cantilever, sir?
cantilever. That's correct. This is a cantilever beam. Na-discuss na ninyo sa inyong mechanics of deformable bodies? Were you able to discuss that? Wala mo ka-discuss? Nakakuan ra mo nga yun na rin itsura sa cantilever? Mingaw man. Wala yun. Which means wala yun ninyo ma-discuss. Okay. So, we are going to establish a state of static equilibrium. No? Meaning, the summation forces X, summation forces Y, and summation moments in the body should be equal to 0. Meaning, if there are acting forces, there should be reacting forces to counter it so that it will become 0. Along the horizontal axis, What are the forces acting? Along the horizontal forces, along the horizontal axis, what are the forces acting?
Ang load, sir.
Kini, this is horizontal axis. The load is only 10,000 pounds. Along the horizontal axis, or summation x, or summation horizontal, what are the forces acting?
None, sir.
Wala. Okay. Tubag dahil aron madali ta. Okay. So we don't have to worry about that. Summation forces horizontal equals 0. 0 man kay wala man. How about vertical?
10,000 pounds.
Your 10,000 at the end is the only one that is acting. Now if we sum forces here, will we get it 0? Will we get a 0 value summation forces vertical?
Sir.
Oh. Unsa man? Huh? Are we going to get forces equal to 0? Summation vertical? Murag wala mo ko ga klase, wa may mutubag. Unsa ta?
Yes.
So, 1,000 equals 0. Is that what you mean? Summation forces, 1,000 equals 0, or 10,000, sorry, equals 0, because there's only one here. So, unsa ko man nato pag 0? Now, the one that is
Applyan og normal.
unsa to?
Applyan og normal force, sir.
Okay. Asa man ang normal force?
Directly opposite sa direction sa 10,000 pounds.
Asa adapita? Which part of the beam? Now, which part of the beam? Remember, the one that is holding the beam is only this part, kinira. So, that is the load. So, we can have a reaction only on the part that is part of the beam. So, asa man ang atong reaction, ani? So that it will be equal to 0. 10,000 equal to 0. Summation of forces vertical equals 0. So naagyo tayo vertical pod nga upward, which is equal to 0. So that if we sum vertical, forces vertical equal to 0. So asa man? Asa man ta mo butang og reaction?
Last support, sir.
Sa support. Dere. Dere sa support. Okay, it should be what directed? What is the direction?
Upward, sir.
Upward. Okay, so I'm going to place here a reaction which is, I will just say an R, which is equal to 10,000 pounds. So, sama, summation forces vertical, okay na ta? Will it be equal to 0?
Yes, sir.
Okay. Now, are we through with the conditions of static equilibrium? Have we satisfied all the conditions when we test for static equilibrium? Humanatag summation forces horizontal, summation forces vertical. Wa na lain?
Moment.
Okay. Napa di ay? Unsa man? Unsa man to?
Animation of the moment, sir.
Okay. Remember, tulo na siya. Summation forces, horizontal, vertical, and summation moment. Now, if we sum moments, Now, if we sum moments, will it be equal to 0? By the way, this one is acting directly on the one, huh? Sorry. Directly acting on the edge of the anak gid siya. Oh, we take moments. Unsa man? Will it be equal to 0? Unsa to? Usba di ko kadungog. Bungol-bungol naman ta kay senior citizen ha. Oh, dili. Why? Because if we take moments anywhere, if we take moments here, this one will have a moment which is not 0. If we take moments here, mo gihapon, no? Dire kana ra gihapon. So, if you sum moments, it will not be equal to 0. So, in terms of the test for moment, then this is still not in static equilibrium. How do we? So, again, in the reaction, there should be a moment. Okay? There should be a moment. Okay, I'm going to illustrate what is the direction of a moment. There is a picas. Okay. Let us say I have a block of wood, and then there is a force here. Now, what is the tendency? Let us say there is a reaction. What is the tendency for this to turn? Diba, mohana man siya? Do you follow?
Yes, sir.
Oh, mohana na siya, no? Do you follow?
Yes, sir.
Okay, so that there is something that prevents this from turning clockwise, then there should be a portion here nga mubira pa dito, o a portion here nga mudot pa dito. Do you follow?
Yes, sir. Yes,
Oh, do you
sir.
follow? So, again,
Yes,
some
sir.
forces, what's that to? If we sum forces horizontal, then these two should be equal, around ma 0. Is that correct? So now, we have a couple. And this couple is actually represented by a reacting moment. Paigo mo na siya dito. Okay, so, in other words, so ang couple, I've represented it with this one, no? So, I'm going to go back to just to illustrate that. Just to illustrate that is what will happen. So, I'm going to go back here. Then, there should be a moment here to make this in the state of static equilibrium because summation moment is ana man siya, kini is opposite, then this moment is equals to the moment of this one, which is 10,000 times the length. No? 10,000 times the length. Okay, so basically that is the free body diagram of the cantilever beam. Now, the next question actually here, or the next problem here is how we determine the moment of inertia and how do we remember, nasa inyong notes last time, ana is equals to V I B. It could be VA or it could be V I B summation of VA. Kadumdum pud mo ani, no? This is the formula to determine the transverse shear stress. I should be determined, and V bar and A should also be determined. So let's go back to the board where we started. So before we can determine the I, we have to determine the center of gravity or the centroid of the cross-section, because that is where the neutral axis will pass through, no? The centroid or the center of gravity of the cross-section. Now, how do you determine the centroid or the center of gravity of a cross-section? If the cross-section is not rectangular, o ma-rectangle, unsa tangguan? If it is rectangular, then I is what? Isa to?
BH cube over
BH
cube over
cube
12.
over 12. Kini ang B, kini ang H. So H, and this is your neutral axis, which is also on the centroid of the rectangle. That's your neutral axis. So, to determine this, we have to find where the neutral axis. But it is easy for this, or the centroid of the cross-section, because it's easy for this because this is a regular shape cross-section, rectangle man. So sa tunga ra, no problem. Now, what happened if we have a composite figure, meaning dili rectangular, good kayo, regular nga rectangle, but we can subdivide this into smaller rectangles. Okay? So, before we do that, we have to determine the center of gravity. Did you discuss how to determine the center of gravity of a composite figure about a certain axis? Na-discuss na ninyo sa inyong mechanics?
No, sir.
Wala? Okay. So, let's try to explain it here. Let us say you have an area, and then the center of gravity is here. And then let us say our reference axis is here. This is your reference, axis. We are going to locate this. However, we are not sure which part, How center is that, But if we can subdivide this into areas where it is kabaluta sa ilang mga center of gravity, okay. For example, kanang sayon lang, ana. Okay? Let us say this is the center of gravity. Nadaring napita ang center of gravity. From this reference, we called it Y. Now, how do we get this Y? Of course, once we know Y, we already assure the location of the center of gravity on the horizontal axis. So, since we know the centroids of a rectangle, we can subdivide this into that rectangle or pwede po ganang rectangle. Which rectangle do you want? Asa man nga rectangle na ganahan? Kanang ana o kanang ana? What rectangle? In this direction? Ana, putlo na to ana? Or putlo na to ana?
Paigda ra, sir.
Pahigda ra, kana ra.
Yes, sir.
Akong ikuan ha. Ako ibutang direct jutay. Aron. Pahigda. Na. So now, we have two rectangles. Area 1 and area 2. Now, according to the determination, of course, total area is area 1 plus area 2. Oh, you already know that, no? Klaro naman. Yeah. Now, to determine, no, this centroid of the resulting centroid, it is equal to the product of the centroids of the components. Sum of the product of the centroids of the components of area and centroid. Another way of saying it is, okay, this one has a centroid. Ano siya centroid na kini area 1? Sayo naman ay pag-determine ng centroid. Kani area 2, nakapunta yung centroid. So, we are going to call this Y1. And we are going to call this, sorry. Ay, mo man na dire, kaya mo man na itong reference. Sorry. This is your Y1. And that is your area 1. And this is your Y2. And that is your area 2. Kini ha? Okay. Now, another way of saying what I have mentioned is that the total resultant or the resultant centroid times the total area is equal to the sum of the product of the centroids of each component times the area. Another way of saying it is the total area times the resultant na siya. Ang katunan ng center of gravity or centroid of the whole area is equals to sum of unahon laman ako area. Wa man kaso siya, no? Area times, or this is area 1 y1 plus area 2 y2. Okay. Now, since we know the total area and since we know all of this, now the centroid kay regular man siya nga mga figures. Okay? Regular man ang y1 and y2. Regular man na sila nga mga figures, rectangle man na sila, and area. So, what we do not know is only this. No? So, we can solve for that. Okay? Now, your reference could be transferred dire. Then, diyan na po ka magsukod. It doesn't matter og asa imong reference because this is just to determine the location of the y. Kini. Ug dire lain na po na siya value pero ang location on the area is still the same. Do you follow? Do you follow?
Yes, sir.
Okay. So, let's go. Let's go to the other board. Again, another way of saying it is for finding the neutral axis, which is the location of the centroid, center of gravity. What we do is, again, muna akong istorya ganiha. The resultant center of gravity times the total area equal to the summation of the products of the smaller areas, centroid of the smaller areas and the areas. Okay, so let's substitute values. Now, what I'm going to do here is, I'm going to subdivide it into this one, no? So, ang first area nako is this rectangle here, kanang taas nga rectangle. Kanang taas nga rectangle. Nya ang area nako nga kuan lain is kining duha. No, wala nako gyana og putol. Gi rectangle nako and then kini. Okay. So, for this one, what is the total area? What's the total area? So, it is 1 by 6. No, 1 by 6 na siya. Plus, this is 2 by 1 or 1 by, 2 by 1. No, this is 2 by 1. So, that is the total area. The 1 by 6, and you have a 2 by 1, 2 by 1 area. So that is the total area. Barred Y. And equal to, so gibahin man ako ni into a rectangle, unya kini o kini, I will start with this one. Area of this is 1 by 6. Ang reference nato ani is the top. Dire ha? Dire atong reference. So what is the centroid of the upright rectangle from this one? So it is 6 maniyang kuan. So from this reference pila man? Ang centroid niya naman sa tungaan ni pila?
3.
3. Okay. So that is why area times the centroid of the small area plus this area, which is 2 by 1. What is the centroid of this? We know the centroid of this is in the center of this one, but our reference is here. So pila man na siya? So by the way, this is 6 man siya, no? 6. Nya, tunga man siya nimo. So 6 minus, this is 1 inch. So 6 minus, pila?
1/2, sir.
Oh, 1/2, 4.5. So you have 1 by 2. Remember, our reference is here. So 6 minus 0.5 or 1/2, which is 5.5. Kani? No? This is for this area. No? Kani Y bar A for this area. Kani 1 by 2 and 5.5. Now, since there is another area here, and it is still the same, so I just multiplied it by 2. Or you can add it, no? 1 by 2 times 5.5. Do you follow?
Yes, sir.
That is how
Yes,
we
sir.
get this. Now, this is very important because you are going to use this over and over again. So, our unknown here is only the location of the centroid in the vertical axis. Okay, if you simplify this and then divide it by this one, you are going to get 4 inches from the top, no? Because our reference is the top. Muna itong reference. Kanya siya. Okay na ana, no? In finding or locating the centroid in the vertical axis, no? Asa siya. So it is probably here, na siya diri dapita. Or dire, no? This is your barbed wire. And that is the location of your neutral axis. So ang imong neutral axis is here. So now we have located the neutral axis, which is 4 inches from the top, or you can have, if your reference is at the bottom, you should get 2 inches. No, depende. Among reference pwede sa ubos, then you should get 2 inches. Ug mas sa taas, then 4 inches. Wala na tayo problema anang kuan. Ha? Wala tayo problema anang how to determine or locate the centroid of a composite area. Actually, pwede man po mo na iputlon diha, no? Duha ra ka book area imong problemahon. I did it this way kay mas a little bit complicated na siya. You try. If you are looking for exercises, then you try to cut it this way. And yeah, see if you can get this y is equals to 4 inches from the top. No, ano mo pagputol. Okay. So now, the moment of inertia. Ato na po kustikas. Total moment of inertia is equals to moment of inertia about its centroid plus area. Isa to, y bar na ko na siya. Y bar ba ni akong kuan? Can you recall? Y bar na ko ni. Sige, balik-balik na yung y bar. But this time, ang definition sa y bar is not the same. Ato bang transfer?
AY bar squared, sir.
Squared. Pero y bar na gyapon ni siya.
Yes, sir.
Now, this y bar is not the centroid, but this is the distance between the axis. Okay? So, if, for example, you have an area here, and you know the centroid of this area about its the moment of inertia about its centroid, or you transfer na nimo siya diha ang reference, then you would say that the total now, or the kung lamang siya, 1 lamang na ko ni. I sub 1. The moment of inertia about the one axis is equals to the moment of inertia about the centroid plus the area times this. Kana. Square na siya. Any question with that? So, what will happen if there is another area? So, what we do is, we do the same, but ang atong reference will still be the same axis. Because once we have converted this into the same reference axis, we can add them all. No? We can add them all. So, ang moment of inertia now of that whole, basig na anak nila in the ring, area to. Na area to dire. Then, pupo niya yung centroid. Yan na po siya ikuan. Then, you have to add that here. Because, this time, parehas naman sila reference axis nga 1. You can add now the moments of inertia. Okay, do you follow? No? Let's try to see if you can trace the. Okay. So, we are now going to find the moment of inertia of this. Okay. We will start with the vertical. We are going to transfer or refer the moment of inertia about the neutral axis or where the centroid is, neutral axis, which is 4 inches. Okay? So it is the moment of inertia of this one about its centroid. Unsay moment of inertia of a rectangle about its centroid. All the formulas that I have given are actually the formula of moments of inertia about the centroid. So, ang rectangular should be what?
BH cubed over 12.
BH cubed over 12. So, where is B here? Kanya nga rectangular, ha? Where is
1.
B? This one. And H is this one. Kana, no? So, B H cubed over 12. This is your moment of inertia about the centroid of this upright rectangular body. But its centroid is here, no? Which is 3 from the top, no? Ito nga man siya. Kabalo po na. Because this is a kanang common regular shape na rectangle. So naadre 3. What is the distance? You are now going to transfer to get the moment of inertia. You are now going to transfer the reference from the centroid to the where you want it, and it should be in the neutral axis. So that is your y bar squared. So what is that? Now what is that? Mona ni siya.
1.
So this is 4 and this is 3. So it is 1. So area times y bar squared, 1 squared. So this is now the moment of inertia transferred to the neutral axis of this upright rectangle cross section. I'm doing this slowly because aron as much as possible makasabot ta. Okay, we are now done with the upright rectangular section. We will start with the left side rectangle. Now you will notice I only multiply this by 2 because these two are about the neutral axis. They have the same, no? They have the same situation or condition. Okay, so for example, the moment of inertia of this one sa ganito rectangle,
BH cubed over
what is
12.
B?
2.
H is 1. Okay, so BH cubed over 12. That is the moment of inertia about the centroid. Napo ng centroid ani dire. What is barbed wire squared? It is the distance from the centroid of this to where we want the reference, new reference, which is the neutral axis. So pila man ang distance?
1.5.
Remember, this is 4 man na siya, no? And this is 2. Yan naman sa tunga, 1.5. Okay, so that is area, which is 2 by 1 barbed wire squared. Okay na ta. We are done with this. Let's go to the other side. It will still be the same. Area is the same. And barbed wire squared will still be the same. So ako rin hindi multiply of 2. Pwede ra pong musulat mo, and then you rewrite this again. And we will have a moment of inertia of 33.3333 inch to the fourth. Ang unit for moment of inertia is length to the fourth unit, no? Length to the fourth unit. For this, it is inches to the fourth. If it is in metric, then probably it is in meters to the fourth or millimeters to the fourth. No questions regarding finding the centroid and finding the moment of inertia transferred to a new axis, which is the neutral axis?
Wala, sir.
Yan na, okay. So let's go now to katong bar, V bar, ito to, V bar A. V bar A. Okay. Now, before we proceed with that, let us look at, okay, remember, ang formula ato is, ang formula ato was V I B if it is only a single regular shape, isa ra ka buok V bar o isa ka buok A. However, if it is made of composite figure or composite meaning made up of many areas, then mura gyapon na siya. IB meaning this value here is the same but we sum V bar A. Okay. So, what is A? Kani nga A? Kani siya nga A? Unsa ni siya? Or kani? You go back to the notes.
Total area, sir?
In that formula, it is not the total area. Katong definition ba nato sa
Cross-sectional area, sir,
cross-sectional area of what?
of the beam between the outer fiber
Between the
of the
outer
beam
fiber
to the
and where?
line. To the line where shear stress is
Where
desired.
you are interested to determine the shear stress. Okay. So, balik ko this speakers ha. According to the problem, we are interested to find the transverse shear stress where? 3 inches from the top. So, tunga-tunga siya dire. Okay, in other words, we are going to find the transverse shear stress here, 3 inches from the top. So, what is A? Atong A nga. Kini nga A. So, meaning, since it is from where you want to find, no, the location, where you are interested in finding the transverse shear stress to the outermost fiber, so you have two options. It's either from here going to the top or from here going to the bottom on the outermost fiber. Which do you think is simpler?
Nung sa top, sir.
Okay, why is it sa top? Ano sa top man ang simple?
Usa ra man ka rectangle.
Okay,
ang
Sarah, it
area.
is only one regular shape. Meaning, kadira siya, V, isa ka V o isa ka A. However, if it is not a regular shape, then we have to sum the different shapes, no, of V and A. Okay, go back. So, I can consider kining A, letter A na ko, kini siya. Ang letter B na ko is kini nga shape, no? You will notice akong gi-shadean. Nakita mo sa akong shading?
Yes, sir.
Okay, kanang na ay ana cross yung shading, that is for A, na? So A, kini. Ang solution ana is for A. Kining shading nga diri sa ubos is for B. Although you are not required to solve, no? Both kay kuan raman. So if you choose the simpler, then you go to the top. Okay. So for A, what is the area? It is the area where you want to find the transverse shear stress to the outermost fiber. So, pila man na?
3 inches.
3
It
square
is,
inch.
ikuan ang dimension.
1
It is
3 by 1.
1
1 and
by 3.
3.
1 by 3.
That is your 3 square inch. Now, your V bar, isa itong definition sa V bar?
Distance from neutral axis
Neutral
to
axis
centroid.
to centroid
Okay.
of the area. So, kini man sila pares, V niya A. So, V bar is the distance from the neutral axis to the centroid of this. Kini. So, how much is it? This is our neutral axis. Ang centroid ani is here. Tunga-tunga aning 3. So, how much? It is 4 minus tunga-tunga ani is
1.5.
1.5. So, 4 minus 1.5, that is your V. Okay. So, let's go over this kini letter B later, no? Atura na siyang kanon later. So, kini rasa because there's only one requirement. You either go to the top or go to the bottom, no? So we'll choose the simpler area. So ang atong formula is this one. So actually, unsa man ang B ani? I'll go back to one figure. Unsa nang B? Boy nga letter B ha. Sorry. Kani nga B ba? Kini.
Width of
Width.
cross-section.
Oh, with the cross section. So what is B?
1.
1. Because the width of the cross section where you are going to find the transverse shear stress. So kana width of the cross section. Of course, we already know what is I. We already know what is I. And we know what is already V and A. Kini na lang V. V is the shear. Go back. Shear. Now the problem is, how do can we determine the shear diagram for this? Unsa may shear diagram ana? Nyara ang atong kwan. I'm going to go back to how do we draw the shear diagram of this? It is based on the load, di ba? Di na takabalo sa ikuan. From the 10,000 pounds, asa man pa ingon ako shear diagram.
Pataas 10,000, sir.
Okay. Storya dayon karon dili ko magkuan og you have of course 10,000 dire, di ba? Kuan ra diagram naman di na naaro, no, diha. Let us say this is your 10,000. From here to here, what is the shape of the shear diagram?
Straight ra, sir.
Straight ra, asa straight, horizontal, vertical.
Horizontal.
Okay. So it is this way. Up the end, asa nang paingon?
Pailalom, sir.
Okay. So you have 10,000 and you go down 10,000. So this is actually 10,000 pounds. That is your shear diagram. Now, if you notice, the shear all throughout the length of the beam is equal to 10,000. So even if you take the transverse shear stress anywhere, your V will be equal to 10,000. That is why, in the problem, it is not being specified asa kadapit mo kuha og transverse shear stress. I'll go back to the problem. Niingon siya, find the transverse shear stress in the material 3 inches from the top of the surface. Pero which part of the beam? Dire bang dapita? Dire bang dapita? Dire ba? And it does not matter because the shape of your shear diagram is the same value of shear. So wala. However, if it is not, ug ang imong shear diagram not as simple as this. For example, ang imong shear diagram is something like this. And probably like that. Dili na ni, these two are not equal anymore. So you have to specify. Kinahanglan, dire ba siya or dire ba kay you are going to use the value of the shear at the location of the beam. Now for this again, it is not being specified because anywhere in the beam it is 10,000 pounds ang shear. Okay, so nanata. So now we can solve this, no? Kanang VIB, kani VIB VA. Okay? So, for figure A, our V here is 10,000. This is the moment of inertia I, and this is our B, being a boy, huh? And this is our V, and this is our A. Okay? And it will give us 2,250 pounds. You try to bring your calculator so that you can check. Ma-exercise ko na yung tudlo o split ano yung calculator. Okay, so this is the result considering the area which is towards the outermost fiber on the top. Insakto ni? You try your calculators, no?
Yes, sir.
Sakto ra, sir.
Sakto ra. Okay. Now, let's say we don't want a simple exercise. We want a complicated exercise. So we are now going to look at the area at the bottom, no? From the location where you want to find the transverse shear stress to the outermost fiber at the bottom. So now we are going to use the subdivision of the different rectangles sa katong pag-solve nato sa atong moment of inertia o katong atong kining center of gravity. Pagbahin nato parehas ra, no? Okay. So this area here are 2 by 1 and this area here is 1 by 3. 1 by 3, no? Okay. Now, so for area 1, it is this one, 2 by 1. And V sa 1 is what? Distance from the centroid to where? Centroid nga na dire, to where?
Neutral axis.
Neutral axis. So, pila man na? This is 2.
1.5.
Minus 0.5. So, 1.5. Yan na siya. Do you follow? Okay na?
Yes, sir.
Yes, sir.
Let's proceed with the upright lower rectangle. Pila ang iyang area? It is 1 by 3. 1 by 3. Pila iyang V bar. So again, centroid of this to the
Neutral axis.
axis. Centroid
0.5.
of this is 3. Di ba? And this is actually ang neutral axis, sorry. That's correct, no? 3 ni siya. Dire sa 3. Yeah. Kini is 3 ni siya, no? And then, so kini 3 man. So katunga ni siya sa 3. Distance between, sorry. Neutral axis man dahil. Sorry. From the neutral axis, this is 2. Is that correct? And your centroid is from here, it is 1.5 because 3 man eh. Do you follow?
Yes, sir.
So, kani siya is 2. Ang centroid aning imong rectangle is 1.5 from each end. So, pila man ang distance?
0.5.
Distance between the neutral axis and the centroid of the second area. So, it is 0.5. Okay na ta? So, let's proceed with the third one. And you will notice that it is similar to the first area. Okay? Ang area niya is still 2 by 1. Ang B-bar niya is still 1.5. Okay, nara. So, ang V na to, akong sulayanin. Nilimtan ako sulat. Area na, B na to is 1 inch. So, in that case, we are going to follow this one. So, VIB 10,000, IB summation of the V times A. So for the first figure, it is what? V times A, no? Is 1.5 times 2. For the second figure, it is 0.5 times 3. And for the third figure, is still 1.5 times 2. Okay? Muna siya, no? So, 1.5 times 2. This is for the first figure. The second figure is 0.5 times 3. And the third figure is 1.5 times 2. And you try to compute this.
2,250,
Okay.
sir.
So you will notice that it doesn't matter. You are still going to get the same answer. Whether you are using the summation or you are using this one. This is simpler because there's only one area. Area between the neutral axis, area between the location of the transverse shear stress to the outermost fiber. Unya, ang atong B bar is the distance from this area, centroid of this area, to the neutral axis. Okay? So I'm going very slow in this because all of this, it's very important to determine this properly because later on, maggamit ra gyapon mo ani if you have composite figures of beams. Okay, any question?
Ay, question, sir.
Go.
Atong sa Pecas board, sir, tong sa Y-bar.
Isa
Isa
man.
ning, isa ning 5.5 nakuha, sir.
Okay. This one. Are you
Yes,
talking
sir.
of this?
Yes, sir.
Okay. So, this is the total area, no? Total area, which is 1 by 6 plus duha ka 1 by 2. No? 1 by 6, duha ka 1 by 2. That is the total area. Now, the upright is 1 by 6. Unya, ang reference nato is the topmost portion, no? Top, from the top, no? Atong reference. So, ang iyang location of the center of this is in the middle of the rectangle, which is 3. Sakto na siya. Okay na ta.
Yes, sir. Yes, sir.
Plus, kani. Area is 2 by 1. What is the centroid of this from our reference?
0.5, sir.
This is our reference, ha? The centroid of this is on the middle.
1.5, sir. 0.5.
Asa man ang 0.5 gikan? Asa ang 0.5 gikan?
Central area 1.
1 by 2.
O, ang kining 1 by, o kining 2 by 1, o 1 by 2, na iyang centroid diha. Pero, asa man ka musukod anang iniyong kang 0.5? Asa man napaingon? Gikan dire? Or gikan dire ra?
Dia ra sir. Dia ra.
O nya, mo na atong ipangita.
Dili.
Dili,
O,
sir.
asa man na itong reference?
Tayong
Pinakataas.
taas.
Okay. Did I answer your question?
Oh, yes, sir. Nakuha na rin, sir.
Ha?
Yes, sir. Yes, sir.
Okay. Mo na yung 5.5 because that is 6. Kanya, 0.5 from the 6 minus 0.5. So, 5.5 ang atong kuan. Kani. So, it is very important na di mo maglibog. This reference should always be the reference of all the areas that you are taking the moment. Actually, ang tawag ani nga kuan is this is moments of areas, no? Moments of areas. Kini the total area times the moment, times the distance. Distance times area is Ug ma-force, it is distance times force. No? Muna yung moment. However, area man siya, so moments of areas. Area times the distance. Ang distance lang ani is from our reference axis is equal to mao gihapon the small area, area 1 ba na siya, times the distance from our reference to the centroid of this area. Plus, napanay kaduha, 2 na pod. So, AY2, which is the centroid distance from the centroid of A2 to the reference axis. Any more question?
Wala na, sir.
Are you sure, ha? Wala na? Kay... by the way, I'm going to illustrate here.
Sir,
Yes, go.
pwede kaning sa kuan sir sa inertia
Oh,
neutral.
what about the moment of inertia?
Pwede ako ipa-explain ng gusto sir para para kaniya nakuha man gud nako tong imong bar Y. Ito ko gi-explain ng gusto. Pwede og ini sa dire. Kung ata gipanguha ng mga area dila ka ng 1/6 by 1 to
Unsa may formula sa moment of inertia? Transfer moment of inertia. Nyara. We are going to transfer this time. We know the moment of inertia of the rectangles. And they are referred about their centroids. Kanang BH cube over 12, muna siya ang moment of inertia about its centroid. Pero i-transfer na to a new axis. Munang butang na to y bar squared, where A is the area of this kaning gikuha ni mong moment of inertia, ang bar y squared is the distance from its original reference, which is the centroid, to a new axis. Kasabot ka? Do you understand this?
Yes sir, yes sir. Okay sir.
Gibalhin nato ang atong reference not from the centroid but to a new axis. So kining bar y importante ni siya because it is the distance from the centroid to the new axis. So let's go back to the other board and let us trace. Okay? Okay na? Saman?
Okay na, sir.
So, mubalik ko atong sa moment of inertia? Kinsa man to ni kuan nga ipa-explain.
Sir, okay sir. Balik sir.
Oh, sige. So tidayon kay abi na ko nakasabot na mo atong dito pag-explain ako. Okay. So, for this one, we have a composite figure which is a standing or upright rectangle and two rectangles that are kanang gahigda, no? Let's start with the upright rectangle. What is the moment of inertia of this about its centroid?
Ano sir? BH cube over 12 sir.
What is B?
1.
1, sir.
H is
6.
6.
6.
okay. Isa na to. B H cube over 12. This is the moment of inertia about its centroid. Asa man ang centroid ani? Na dire. Of this one, no? Na diha. So kanang BH cube over 12 or 1/6 cube over 12 is ang iyang moment of inertia. Ang reference nato is the center of gravity or the centroid of this rectangle. But is that where we want to find the moment of inertia?
No sir.
Asa man?
Ari sa 4.
Unsay tawag ana?
Neutral axis.
Neutral
Okay.
axis.
So we are going to find the moment of inertia about the neutral axis. So area, so na part nga area bar y squared. So what is the area? Of course, it is the 1 by 6. And bar y square is the distance from the centroid of the rectangle to where we are going to transfer the reference of moment of inertia, which is in the neutral axis. So pila man eh?
Okay,
1,
sir.
sir.
So okay na eh?
Okay, sir. Sige, yes, sir.
Okay na. So let's go. Just to expound further. Kanina pod. Forget about the two. Let's look at this. What is the moment of inertia of this one? About its centroid.
BH
0.5,
cube over
sir.
12.
Kung sa man ang B.
2.
Then H
1.
1, sir.
over 12. So 2 times 1 cube over 12. Muna siya ang moment of inertia of this area about its centroid. But we transfer it to the where?
Neutral axis, sir.
Okay, so kinahanglan ta og area bar y squared. And bar y squared is the distance from the centroid of this to the neutral axis. Pila man na?
1.5.
1.5, sir.
Sir.
Yeah. Kuhanin mo 0.5. So 1.5. So area time bar y squared. So all of this inside the parenthesis is this one. However, you multiply rin ako og 2 because there is another one here. And it is the same. Parehas na magyapon kag bh cube over 12, bh cube over 12. And then your a is also the same. Bar y squared is also the same. So ako rin i-multiply og 2. Okay na tayo na?
Yes, sir. Kuha, sir.
Oh, kuha na. Actually, ang
Copy, sir, copy.
ang confusing kayo ani is actually katong V bar A. Ang V bar A gyud may murag makalibog. Kani. Ay sorry. Kani mga V bar A. Because area, of course, we know area. Pero ang area is from where we want to find the transverse shear stress to the outermost fiber. Kung maisa ra ka area, kinira. If matulo ka area, mao ni siya. Kay ang nakakomplikado ani kay mangita ka og centroid sa area to the neutral axis, di ba? Centroid ani area to the neutral axis, centroid ani area to the neutral axis. Nya imo na siyang gi-subdivide into two okay? Para sa ani, pila may kuan, this is 2 and this 0.5, 1.5 na siya. That is for the B bar. Kanisya is the form, is the moments of areas, no? If you want to find the centroids of the total resultant area, then it is equals times the area equal to the sum of the small areas times their centroid from the reference, the distance barbed wire from the reference. Okay? Muna siya nga kuan. Now, be careful with this formula because if your reference is not, no, wala siya kaning mga distances siya ko ano? Kaning mga distances are in one side of the reference axis. Atong reference axis ani diri man, no? And they are all one side. Now, if in case ang atong reference axis is nasa tunga, kining mga y has a sign. Asa ka mo assign dito sa PCAS. For example, na atong reference axis dere. Ang centroid ani kana nga distance, ang centroid ani kana nga distance. Since they are in opposite sides of the reference, mukari og sign ning imong mga y. It depends on you og asa imong i-assign dito sa PCAS negative, di sa PCAS positive. So, in other words, if you are just going to decide og asa imong reference, it is best to have a reference nga one side ratanan ang imong area. Like this one, no? Mura ra na siya og the moment ka, no? Moment of forces. Na adre pangitaon nimo ang center of gravity. Ana, asa man ni siya mo balance? Na ay ang center of gravity, diha. Oops, probably here. Kulang pa. Ni balance na siya. So na ay ang location sa center of gravity, which since this is a uniform body, then it is the same length from here to here. Na diha sa tunga imong center of gravity. However, ug maimo ni siyang naapay madugang nga area dere. Na madugang nga area dere. Even there, no, na madugang nga area. Muirog na imong center of gravity to that side. Isa, naman to dere ang atong center of gravity, no? Kana. If I'm going to place this here, muirog na imong center of gravity dira, dapita. Na, okay. Diyan dapita. Ay, sorry. Sorry, wala ko kakuan. Okay. I'm going to illustrate. Mobo raman ng kuan. Ana, makita na ninyo? Makita na ninyo ang kuan? Akong illustration?
Yes, sir.
Yes, sir.
Niha, sorry, napamubo na ko. Na ang center of gravity. Ang center of gravity is where ang imong area or forces mo balance, no? So, let's say na naaning area diri o kaning area diri. They are identical. So, naa sa tunga nila. However, ug mabutangan nato area ang lain diri, of course, we expect nga moirog ang atong center of gravity there. Nandiring kapita. Oh, tira ra na o ni balance kay gyutay. That is the best I can explain about center of gravity or centroid. Ana tingali. Oh. Kana, oh. Isud pagkuan. Basta hapit pa siya mo balance, no? Ug kuhaon ako ni, moirog na siya dire. Diring dapita. Okay? That is the concept of center of gravity. For areas, then area ang imong gikuhaan sa center of gravity. But for forces or for mass, or weight, ang weight na pod or ang mass ang imong gikuhaan og center of gravity. Okay, any questions?
Good afternoon, sir. Mangutana
Yes.
lang ta ko atong sa kuan sir katong referring to figure B na V tab sub I atong
Ay.
0.5,
Sa
sir.
buwan, okay, go.
Anong na 0.5 siya, sir?
Okay, kini. What is V?
Sir.
It is the distance from the centroid of... sorry. Ito ni siya. Sayop ko. Sayop. Sorry, nasayop ko ha. Kini siya mo V bar 1. V bar 2 ni. Nakulangan ukan. Sorry. So it is this one. Ako i-explain?
Pwede, sir.
Okay. Okay na ning area. Okay. We're talking of this one, ha? Ang tindog. Because to is, kana mga tindog.
Sir.
Pero dire na siya taman, ha?
Yes,
Because
sir.
remember, the area is the composite areas that is either from the location where you want to find the transversal stress to the outermost fiber. Paingon dito sa taas or paingon dito silong. Okay, so for this one, mao na ni. No problem with this? For this one?
Okay na siya, sir. Nasabta
Same
na
ng area. Ang distance from the centroid of this area to the neutral axis. Kini ikaduha. It is, the area is of course, kuha na siya, 1/3. Ang centroid ani is, where?
1.5.
1.5 from here to here, from here, no? Also from here, 1.5. Now, however, the V bar is the distance from the centroid to the neutral axis. To the neutral axis. Do you follow? So, V bar is from the neutral axis to the centroid of this. Nya kana is 2 man na siya, nya kana 1.5. So, ang iyang distance is do you follow? 1.5 ni, di ba?
Yes,
Ang
sir.
centroid ani may area. Pero where is the neutral axis? It is here, which is 2 na siya from the... So, pila man eh?
0.5.
Oh.
Okay,
Kini.
thank you, sir.
Muna, that is where, that's the part where it is confusing. Basta, imong gipiling area is a composite area. No, daghag kuan. Isa pa. Wala na? Now, in case you have problem or questions later, no, you have to raise it. Okay. It will be your disadvantage of magloom-loom ramo nga you have so many questions in your mind, you do not voice it out. So, silence naman. Okay na ta? Okay na ta?
Yes, sir.
Yes, sir.
Sige, so you take your screenshot. Let's start with that board. So again, it is, you start also to review your mechanics of deformable bodies kay magsugod man ta sa stress, sa shear o sa moment diagram. Okay na ta? Let's go to the other board. Nahuman na?
Yes, sir.
Okay na?
Okay na, sir.
Okay. So, for your exercise, o mangita gyud mong kuan, you can use this problem. Pero ang imong bahin ana. O you try to say, ug manaay diferensya ug di maparehas, then there's a difference in your solution, no? Or there's a you have no ana pagputol. So duhara ni siya ka rectangle, upright and a lying rectangle, no? So duhara siya. So you start solving the center of gravity of this using two. Then sunod, you also start solving for the eye of this using higda ra og patindog nga kuan. Dili man ani nga pagkabahin, no? And you would find out na there is no wala ra siya kuan. In fact, anaon man ta nako ni og kuan. Og divide pero ingko nga mas maayo ning lisod-lisod. Kaya aron naapuntay exercise insakto. So, okay na tong kuan, no? Naka-screenshot na mo on both boards.
Yes, sir.
Okay, sige. So, I'm going to ask you again to turn on your cameras. And then I'm going to take a screenshot of your faces, no? Just to document that we are having classes. Okay na ta, no? For this afternoon, we are done. Paspas naman ta tong ano, gamay ra kayo ning isang nga topic but I made sure nga I have to go slow aron you can follow, no? Sige, okay na.
Thank you, sir.
Okay, you're welcome, no?
Thank you, sir.
Sige.
Thank you,
okay.
sir.
Bye, no?
Thank you, sir.
Sige, you're welcome.
Sir,
Okay.
thank you.
Bye-bye.